Hey everybody, in this video we're going to talk about unit vectors. What is a unit vector? Well, a unit vector is a vector of length 1 unit, in any given direction. Okay, so a vector, a unit, 1 unit in any given direction. So let's say we've got this vector here. We'll call this vector A. So remember, a vector goes over on your x and then it goes up or down on your y. So in this case we went over 3 on our x and 4 on our y. So A is equal to 3i plus 4j. Okay, so how do we find a unit vector? Well, first we have to find the magnitude of this vector A. And the magnitude, remember, if you're not familiar with this, go back to the video where we do talk about magnitude, and that might help a little bit. But basically we're going to take the square root of 3 squared plus 4 squared. So we've got the square root of 9 plus 16, square root of 25, so we've got a length of this particular vector A of 5 units. Now let's say we've got another parallel vector, and going in the same direction as A, but we're going to call it B. And we want to make this 1 unit in length. So we already know that A is 3/4, or not 3/4, 3 in our x and 4 in our y. And this B is parallel to that, so all we need to do is multiply it by a scalar to get what B is. But if we take 1/5 times A, that should give us the length of B, which we want it to be 1 unit. And let's see how that works out mathematically. So if B is equal to 1/5 times 3 and 4, 3 for our x, 4 for our y, then we have B is equal to 3/5, 4/5, and when we find the magnitude of B, it's going to be the square root of 3/5 squared plus 4/5 squared, which is square root of 9 over 25 plus 16 over 25. Well, we already saw that 9 and 16 is 25, so we got 25 over 25, which is 1. So what we've just done by multiplying A by a scalar of 1 over the magnitude of that, we've basically just turned a vector B into a unit vector. So let's look at how this kind of plays out in formal definition here. So a unit vector is 1 over the magnitude of A times A, or the magnitude of B times B, or whatever that vector is, 1 over that magnitude times that vector. Or another way we can say is just vector A over the magnitude of A. Right? That's just simplifying those fractions. So this is kind of the key idea for making that unit vector. So if we wanted to find any vector of some length and of some length k in the direction of a vector A, so if we wanted to find any vector length k in the direction of A, then if we find the unit vector of A, we can multiply that by k, and then the vector k times A over the magnitude of A is our unit vector. Sorry, it will not be our unit vector, it will be length k in direction of A. So this is kind of a different idea. So this is now taking that unit vector and changing the size to a given size that we want. So what we're saying here is we've got some vector A, and we want it to be length k, whatever that is. So first we convert it to a unit vector, and then we multiply it by k to grow it back, or to expand it or shrink it to whatever that scalar is of the unit vector. Alright, so let's see if we can see this in an example. Hopefully this will make a little bit of sense. So we want to find a vector length 10, a vector of length 10 in the same direction as the vector 3i minus 1j. Okay, so 3i, the magnitude of 3i minus 1j is going to be the square root of 3 squared plus negative 1 squared. So we get the square root of 9 plus 1, so the magnitude of this is going to be the square root of 10. So that's the length of this vector. So if we rewrite this vector as 1 over square root of 10 and 3, negative 1, that's given us a unit vector. That's going to be a unit vector of size of length 1, right? So that's just following what we did up here in the purple. So we want to now make this the length of 10. So we want to multiply this basically by 10. So that's all we're going to do. We're going to take this idea where we've got k times 1 over the magnitude of a times a, and we're going to do the same thing. So we're going to take 10, which is our k, times 1 over square root of 10, which is our magnitude, 1 over the magnitude of a, and we're going to multiply that by our vector a, 3, negative 1. So when we simplify, we can just say 10 over root 10 times 3, negative 1. Now, we tend to not like vectors or anything where we've got a square root in the denominator. So we can rationalize this function or this vector equation by multiplying by root 10 over 10. So we're going to do that, and then we get 10 times square root of 10 over 10, right? Because square root of 10 times square root of 10 is 10, and then the numerator is just multiplying those two values together, times 3, negative 1, and our 10s cancel out, so we're left with root 10, 3, negative 1. So strangely enough, this is our vector of length 10 by multiplying it by this square root of 10. So it seems kind of counterintuitive after we go through all this simplifying, but that's our vector of length 10. Now, something to think about or something to keep in mind, that this square root of 10 is not always going to be the same value as this length of 10. The reason that happened is because we had to rationalize our denominator, and we were and our 10s canceled out. So if we were looking at a magnitude, say we wanted to actually find a vector of length 5 in the same direction as 3i minus 1j, then it may not cancel out and look the same way, but you would still go through this whole process to find the vector of that length. So hopefully that helps kind of combine these ideas of first trying to shrink down a vector into a unit vector length, so it's got a length of 1, and then maybe increasing or decreasing it by some scalar by multiplying by a value of k. Then all you have to do is kind of do some simplifying to get your final answer there. But that's the ideas behind a unit vector and finding vector lengths. I hope that helps, and I'll talk to you in the next video.